Hey guys, this is 1.7. We are talking about imaginary numbers or complex numbers today. So in 1.6, we were talking about how if you have a negative under an even index of the radical, we just say that there's no solution, or we simplify it in a way that doesn't take that negative out of it. But in fact, you can use imaginary numbers to substitute in for that negative sign. So the reason you can't do a negative under an even index is because -6 times -6 becomes positive 36, right? So there's no real way to get two terms that would multiply, or a term that would multiply by itself to get a negative number. We're going to use the letter I in this lesson to replace that -1 that is under the radical so that we can further solve them. All right, so we're working on complex numbers. Complex means it's a combination of a real number and an imaginary number. Good. What is an imaginary number? An imaginary number is represented by the letter I, okay? Remember in 1.6 when we said that the square root of -4, I think it wasn't -4, but the square root of a negative is non-real. I think we just wrote NA, right? So you can't answer this without an imaginary number because this is even, right? This is a 2. So we're looking at for the same number times itself twice that will equal a -4, right? If it were the square root of 9, it would just be 3 times itself, right? If it was the cubed root of -9, it would just be -3 times -3 times -3. Negative times a negative makes a positive times a negative makes a negative. So you can get to -9. Sorry, you can't get to -9. You can get to -27 by multiplying three negative numbers, right? But if I wanted to get to a -9 by only multiplying the same number, -3 times -3 gives me a +9, right? So that doesn't work. +3 times +3 gives me a +9. And -3 times +3, those aren't the same number. So that doesn't work either. So that's why if your index, if this number right here is even and this number is negative, you cannot solve it without an imaginary number. There's no real number that you can multiply by itself to get a negative number. Okay? Therefore, we create an imaginary number. The imaginary number is just the letter I, and what I is the square root of -1. So anytime I have the square root of -1, I can just call it I. The square root of -4 now becomes -1 times +4, right? -1 times 4 is -4. And then that becomes I square root 4. And then the square root of 4 is 2, so that's just 2I. Okay, so I exists to replace the square root of -1 so that we can solve this now, right? The square root of 4 became the 2, the negative sign or the -1 became the I. So the square root of -1 is I. The next part to remember of this is this equal sign means these are equal, right? If I square the square root of -1, the square root of something squared is itself. Good? The square root of something squared is itself. The square root of 100 is 10, but the square root of 100 squared is 100. So the square root gets rid of the radical sign. So we're just left with -1. And if I have to do this, if I have to square this side, I have to square this side to maintain equality. So I squared equals -1. Okay? So by definition, the square root of -1 is I, and I squared is -1. If you just square both sides of this equation, you get this equation. Good? So that's called an imaginary number. The imaginary number is represented by I. Complex numbers is when you combine a real number with with an imaginary number, right? So the real number is the number 7, for example. The imaginary number is the number 6i, or just the number I, 1i. Okay? Complex numbers are written in the form a plus bi, where a is the real number part and bi is the imaginary part. So a is real, a real number, and bi is an imaginary number because it has the I. So I isn't really a variable, but in a lot of cases you can treat it like a variable, okay? It's the symbol that we put up to represent the square root of -1. So now they're asking us to write square root of -9 in terms of I. Let's think about if this were just the square root of 9, right? If this were just the square root of 9, we would say, well, 9 is 3 times 3. Because the index of that is 2, I'm looking for two numbers that multiply times themselves, and I can take them out. So the square root of 9 is the square root of 3 times 3, which becomes 3. However, that's not what we're doing, right? They've asked us to do -9. So what I do is I take out that -1. Now it's -1 times 9. Then I have that 9. I know what to do with a 9. A 9 is 3 times 3, and then I can take those 3's out. Just like I took the 3's out here and put them here. I can take these 3's out. 3 square root -1. What's the square root of -1? The square root of -1 is I. 3i. Good? All right, let's do another one. The square root of 81. Again, if it was just this, or sorry, the square root of -81. If this was just the square root of +81, we would just say the square root of 9 times 9 is 9, or 81 is a perfect square, so it'll be 9. Here we have to take out that -1 first. So -1 times 81. What is 81? 81 is 9 times 9. So the 9's come out. Square root -1. 9. Square root -1. How can I change the square root of -1? I can call it I. So that's just 9i. And that's my final answer. So this one's 9i. This one's 3i. Good? All right, the square root of -180. I don't think -180 is I don't think 180 is a perfect square, but we can check. The square root of 180 doesn't give me a answer without a decimal, so I'm going to make it into a factor tree. To make it into the factor tree, we separate it from that -1, right? So now it's -1 times a positive 180. Now I can factor 180. 180 I can say is, maybe it's 18 and 10, right? Because it has a 0 on the end. So if it has a 0 on the end, I can divide it by 10. 10 becomes 5 times 2. What is 18? 18 is 9 times 2. There are other options if you want. 5 is factored. 2 is factored. 9, you can factor it to 3 times 3, and then 2. Good? You don't have to do 10 and 18. You can do it with whatever you can come up with. So 180, you can just say 180 divided by 2, right? Is 90. 2 stays the same. 90 divided by 2 is 45. So now it's 90. 90 becomes 45 times 2. That 2 stays the same. 45 is 9 and 5. 2 remains 2. 9 becomes 3 times 3. Good. So either way, we end up with 5, 2, 2, and 3. So it does not matter how you start your factor tree. If you factor it all the way down, you should get to the same prime factorization of 180. So negative 1 times 180 becomes the square root of negative 1 times 5 times 2 times 2 times 3 times 3. Good. Start taking out any pairs you see. We can take out a 2, we can take out a 3. So that becomes 2 times 3. Then we've got negative 1 times 5. That square root of negative 1 becomes I. So 2 times 3 is 6. I square root 5 is the simplest form of the square root of negative 81. Good. All right, same with 200. So here we have the negative square root of negative 200. For this negative sign, I'm just going to keep putting it out in front. I'm not really going to do anything with it. For the negative 200, I'm going to call it negative 1 times a positive 200. And then you can factor 200 however you like. 200, I would say, is 100 times 2, right? Because I know that 100 is 10 times 10, and that 10 times 10 is a good, or that 100 is a perfect square, right? So 10 times 10 under the radical will be, so that was negative 1 times 10 times 10 times 2 instead of negative 200. Good. Which then would become 10, because those would come out, times the square root of negative 1 times 2, which is 10I square root 2. You can also do 200 a different way. So 200 is just what? 20 and 10 maybe. 10 is 2 and 5. 20 would be 5 and 4. 4 would be 2 and 2. 5 remains 5. 5 is 5 and 2 is 2. Then you get the square root of negative 200 is the square root of negative 1 times 200, which is negative 1 times 2 times 2 times 5 times 5 times 2. Five times 2, square root of negative 1 times 2. 5 times 2 is 10. The square root of negative 1 is I, square root 2. So you get the same answer no matter how you start your factor tree. So that is just going to be 10I square root 2. But remember, we're just moving that negative sign that was in front of everything. We're just moving it along with us each time. So that's now going to go here. So it's going to be negative for that negative sign. 10I square root of 2 for the negative square root of 200. Or sorry, for the square root of negative 200. Good. Okay, for number 6, 7, 8, 9, 10, 11. For 6, 7, and 8, we're going to add or subtract complex numbers. Okay. And this is, remember when I mentioned that the imaginary number I is kind of like a variable? You can look at it like a variable when you are combining like terms. So all we're doing here is we're adding the complex number 8 minus 7i to the complex number 9 plus 5i. That's a plus sign. So just like when we were combining like terms, you don't need the parentheses because there's nothing to distribute, right? We're just distributing a positive, so that stays positive, that stays positive. So we have 8 minus 7i plus 9 plus 5i, and then I'm going to group them into like terms. The negative 7i and the positive 5i are like terms. Those are both the imaginary part of the number. And then the positive 8 and the positive 9 are the real number part of the complex number. So 8 plus 9, negative 7i, minus 7i plus 5i. You can write it like, plus sign between them because we're not multiplying, right? We're combining them. But I added those parentheses just to show which ones are the like terms, but we're not multiplying, so we're adding. So we could say 8 plus 9 plus negative 7i plus 5i, or you could say 8 plus 9 minus 7i plus 5i. 8 plus 9 plus negative 7i plus 5i. Any of those are all the same thing, okay? 8 and 9, 8 and 9 become 17. Negative 7 plus 5, it's kind of like 7 minus 5 is a 2i, but the 7 was bigger and the bigger one's negative, so negative 7 plus 5 leaves us with a negative 2i. So that's just basically combining like terms, okay? However, remember, if you have a minus sign in front of a parentheses, you have to distribute that negative. So now we have 9 plus 6i plus negative 3 9 plus 6i plus, and then that's a negative, negative 3, negative, positive I, right? You don't have to do it like that. Trying to make it simpler, but I feel like I just made it more confusing. You're making sure to distribute that negative. So that's that negative sign is right there and right there. Okay? 9 plus 6i plus negative, negative 3. So a negative times a negative is a positive. So plus 3, negative and positive makes a negative, negative I. Or you can say negative times a negative makes a plus 3, negative times a positive makes a negative I. Okay? Now you can group them. 9 plus 3 plus 6i minus 1i. It's just I, but I'm going to call it 1i because I'm taking 6 and subtracting 1, right? 9 and 3 is 12, and 6 minus 1 is 5i. So our final answer here is 12 plus 5i. There's the real numbers, and there's the imaginary number because it has the I attached, okay? Number 8, they're giving us 3 different groups. So we have 7 minus 7i plus negative 5 minus 8i. And I'm just going to combine these and then I'll subtract 7 minus I from that. So that becomes 7 minus 5 minus 7i plus 8i. 7 minus 5 becomes 2. Negative 7 plus 8 just becomes a positive 1, right? 8 minus 7 is just 1. Minus 7 minus I. Remember to distribute that minus sign. So now I have 2 plus I minus 7 minus negative I. Good. 2 plus 1 minus, 2 plus I minus 7. Negative times a negative is a positive plus I. 2 minus 7 to group them, plus I, or plus 1 plus 1. So 2 minus 7 is a negative 5, and 1 plus 1 is 2i. So that's negative 5 plus 2i for that one. For number 9 and number 10, we're going to be multiplying a term times or like a monomial times a binomial. So we're going to distribute that 6i times 6 minus 6i. So this is the same thing we're doing when you have a minus sign out in front. You're just distributing it, right? 6i times 6. We have that 6i times 6. I'm going to put a plus sign between them. You can do a minus sign if you want. Same 6i times negative 6i. So I said you can put a minus sign if you want. That minus sign would go there instead of right here. Okay, so I put a plus sign and made it a negative 6i, or 6i times 6 minus 6i times 6i. So just remember that you need that minus sign somewhere, okay? Either right next to the 6i. If it's next to the 6i, you need to put a plus that wasn't there, but that shows that these are separate terms in front, okay? Or you can just put it out in front and not put it with the 6i. Either way, here we get 6 times 6 is 36i, and then 6 times negative 6 is negative 36. I times I is I squared. Okay, same here. 6i times 6 is going to be 36i minus 6 times 6, so that's minus 36i squared. Okay, remember the rule for I squared. I squared is just -1. So anytime you have an I squared, I want you to change it to a -1. So this becomes 36i minus 36 times -1. Good. I'm not going to keep going over here because these are exactly the same, right? That was just to show that those are the same no matter how you write them. So now I have 36i negative 36 times -1. You can just put that in your calculator if you want. Negative 36 times -1 gives me a positive 36. We have 36i plus 36. You want to flip them around so that the real number is in front of the imaginary number. This was a positive 36, and this was a positive 36i, so my final answer is 36 plus 36i. For number 9. Okay. Number 10, we're going to do negative 6i times -3 plus 9i. So that means we're going to do negative 6i times -3 plus negative 6i times positive 9i. Negative 6 times a -3 is 18i, right? Because there's just one I. 6 times 3 is 18. Negative times a negative is a positive. Negative 6 times 9 is 54. But it's a negative times a positive, so it's a negative 54i squared. So now we have 18i minus 54i squared. What do we do with I squared? I squared becomes -1. So it's 18i minus 54 times -1, 18i. Negative 54 times -1 becomes a positive 54, and then just switch order so that you have the real number in front and the imaginary number in the back for your complex number. So that becomes 54 plus 18i. Good. Number 11 and number 12, we're going to be multiplying a binomial times a binomial. You're basically using the FOIL method, okay? So for number 11, we're going to do 7 plus 3i times 5 minus 6i. First is 7 times 5. Outside is 7 times -6i. Inside is 3i times 5. And last is 3i times -6i. Good. All right. 7 times 5 is just 35. 7 times -6 is -42i. 3i times 5 is 15i. And then 3i times -6 is a -18i squared because it was oh, sorry, you couldn't even see. I times I. Shoot, you couldn't see that whole FOIL thing. I apologize. All right, so 7 times 5 becomes 35 for our first one. Outside, 7 times -6i becomes -42i. Inside is 3i times 5 becomes 15i. The last one is 3i times -6 becomes -18i because positive times a negative is a negative. I times I is I squared. So that becomes 35 minus 42i plus 15i minus 18i squared. Good. We can see that these are like terms, right? Negative 42 plus 15. It's like 15 minus 40, oops, 15 minus 42, or negative 42 plus 15, negative 27, minus 18i squared. What do we do when we have an I squared? I squared is negative 1. So now it's 35 minus 27i minus 18 times negative 1. Negative 18 times 1 is a positive 18. And now these are like terms. So I have 35 plus 18 minus 27i. 35 and 18 is 53 minus 27i as our final answer. Good. For number 12, remember, anytime you see a binomial squared, it's not that. You multiply it by itself, so you FOIL it out. 8 times 8 is 64 for the first term. 8 times 9i is 72i for that outside term. 9i times 8 is also 72i for the inside. And then 9i times 9i is 81i squared. Good. All right, we'll put all of that together. We get 64 plus 72i plus 72i plus 81i squared. Combine 72 with 72 to get 144. And then 81i squared. What is I squared? I squared is negative 1. So it's 64 plus 144i plus 81 times negative 1. So that's 64 minus 81, right? Because positive 81 times a negative 1 is a negative 81 plus 44i. 64 minus 81 is negative 17 plus 144i. Good. All right. Now we are just going to simplify fractions, okay? We have the term 8 minus 6i all divided by 6, okay? What I would do in this case is I would separate this into two fractions. So we have 8 over 6 minus 6i over 6, right? 8 becomes 4 times 2. 6 becomes 3 times 2. Those cancel and I just get I, right? I can cancel this and I get 4/3 minus I. Good. So if I only have one term on the bottom, I like to just turn it into two fractions. 4 divided by 4 minus 3i divided by 4. Those cancel. You don't just write it as 0, you write it as 1 minus 3i over 4. Good. All right, guys, that is it for complex numbers. Thanks so much.